If an exponential equation can be written in the form b to the u equals b to the v, we have the same base, then x has to equal y. 2 to the x equals 2 to the third means x equals 3. The first thing we want to do is we want to figure out what is a base that when I put it to some exponent, I have 8 equals 1 over 16 to the x power. If you don't know how to figure out what base would be, let me help you. If I start with 8, I can do a factor tree. 8 is 2 times 4, and 4 is 2 times 2. Notice all of these are 2's. 8 is the same as 2 to the third power. And if I do the same thing with 16, I'm going to get 2 times 8, and we already know 8 is 2 times 4, and 4 is 2 times 2, equals 1 over 2 to the fourth power. That's 16 to the x, because I have 1, 2, 3, 4 2's. I found a base, and now I have to use my exponent rules. And the first thing I'm going to use is b to the m to the n. We multiply. This equals 1 over 2 to the 4x. 1 over b to the minus m is equal to b to the m, and b to the minus m is equal 1 over b to the m. I can change this to 2 to the third is equal 2 to the negative 4x. Now I have a base to a power equals the same base to a different power. If they're going to be equal, then that means 3 has to equal negative 4x. I divide both sides by negative 4. These cancel. I get x equals negative 3/4. The first thing I want to do here is get rid of that whole square root thing. Let me give you the rule for that. If you have the nth root of something to the m power, that's exactly the same as the nth root of that whole thing to the m power. And that equals a fractional exponent. Let's just do the radical part first. Notice I have this form right here. That equals b, which is the base, which is 3, to the index on the radical is always the denominator. And then this is the numerator. This is going to be x minus 2 divided by 4. I'm using this rule over here. 3 has got to be the base on the right. Is there something we can do with 27? Well, 27 is equal to 3 times 9, and 9 is equal to 3 times 3. This is 3 to the third to the x power. Now this right here becomes 3 to the minus 3x equals 3 to the x minus 2 over 4. I have my bases the same. Minus 3x is equal to x minus 2 divided by 4. And I want to solve for x. Now it's just some simple algebra. I'm going to multiply both sides by 4. That gets rid of my denominator over here. And I get negative 12x equals x minus 2. I subtract x from both sides, and I get negative 13x is equal to negative 2. And I divide both sides by negative 13. This cancels. And my final answer is x equals positive 2/13. Now we want to do a few word problems, but the words are not as important here because they are giving us equations, but we'll read it anyway. Most golfers find that their golf skills improve dramatically at first and then level off quickly. For example, suppose that the distance in yards that a typical beginning golfer can hit a 3-wood after T weeks of practice in the driving range is given by this equation. This function has been developed after many years of gathering data on beginning golfers. D is the distance. We have to know what each of these things means. And T is weeks of practice on the driving range. Then when we're asked questions, we actually can answer them because we know what the variables mean. How far can a typical beginning golfer initially hit a 3-wood? We'll call this A. We'll call this B. We'll call this C. And we'll call this D. And these are, again, just calculator questions. A, how far can a typical beginning golfer initially, this is a very important word, hit a 3-wood? Initially means before I've practiced for any length of time. So T is going to equal 0. D of 0 is equal to 255 minus 100 e to the power of negative 0.7 times 0, which is equal to 255 minus 100 e to the 0. What is e to the 0? Well, anything to the 0 power is 1. So this becomes minus 100, which means that most golfers, when they first start, can hit a ball with the 3-wood 155 yards. B, how far can a typical beginning golfer hit a 3-wood after 1 week of practice? T is in weeks. Perfect. That means I can just replace T with whatever week. I have D of 1 is equal to 255 minus 100 e to the negative 0.7 times 1. And if we do this problem, the answer you're going to get is 175.34 yards. So after 5 weeks, now T is 5, so I get 255 minus 100 e to the minus 0.7 times 5. And I get 221.98 yards. And then after 9 weeks of practice, I believe the last thing was 9. Yep. So after 9 weeks of practice, we just do D of 9, which equals 255 minus 100 e to the minus 0.7 times 9. And that's going to be 224.82 yards. So notice the longer I practice, the further I can hit the ball because I'm subtracting less and less. Another way to see this equation, I start with 255 and then I have 100 divided by e to the 0.7 times t. Because it's negative, it's actually in the denominator. The bigger the denominator gets, I'm dividing 100 by a bigger and bigger number. The bigger the number I divide by, the smaller that fraction gets. and I'm only subtracting a smaller and smaller amount. Exponential growth. A model that describes the population P after a certain time T is where this P sub 0 is the initial population. So let's say you live in a city and the population is 1 million, or maybe it's 100, depends on what size city you live in. And K is going to be greater than 0. If K is greater than 0, it means my population is growing. If K were less than 0, it would mean my population is shrinking. K could be either one, but we're talking about K is greater than 0. K is the constant, and it's called the relative growth rate. And we may or may not be given that. If we're given it as a percent, we need to change it to a decimal. We never work with percents when we do calculations. If you get 25%, you divide that by 100 and you get 0.25. The decimal number is the one we're going to need to use. The population of a small town follows the exponential growth model, P of t equals 900 e to the 0.015. Answer the following questions, rounding each answer to the nearest whole number. What was the population of this town in 1900? In 1900 is where we started getting our information. T is going to equal 0, right? So we would have P of 0, which equals 900 e to the 0.015 times 0, which is really the same as 900 e to the 0. Anything to the 0 is 1, so we just get 900. So those are always the easiest ones. You don't even need a calculator. Whenever an exponent is 0, that whole thing just becomes 1. Now we want to know what was our population in 1950. 1950 is 50 years past 1900. That means T is 50. The answer for this is approximately 1,950 people. Use this model to predict the population of the town in 2012. I have to subtract 1,900 because that's where I started, and I get 112 years later. P of 112 is equal to 900 times e to the 0.015 times 112. And if you do this on your calculator, you'll get approximately 4,829 people. Wow, that grew pretty quickly. First 50 years, I only grew by 1,000 people. But in the second 50 years, I grew by almost 3,000 people. What does that tell me about exponential growth? Well, if we looked at a graph, I'm just going to graph an exponential function. What happens is it starts increasing a little bit slowly. They used to say that about COVID. It's growing exponentially, which could have meant that, once a week, our cases were doubling. So if you double something, it grows quickly. So like the first time, let's say it's 1, and then you double it, it's 2. And then if you double it, it's 4. So this is 2 to the 0, 2 to the 1, 2 squared. Then it's going to be 8, 2 to the 3rd. Then it's going to be 16, 2 to the 4th. If you keep doing this, by the time you get to 2 to the 10th, it's 1,024. Think about it. X, this is really 2 to the x. So x is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. By the time I get to the 10th number of x, I can't really graph it anymore, right? Because it's just too big. So that's what happens with exponential growth. It grows really quickly.